round of applause for both of them on the stage.
Just doing a sound check. Am I audible to everybody? Perfect. Am I just audible to all of you guys in front, or can everybody hear me at the back? I expected a little bit more energy from Hyderabad, because the last time I was at your meetup, I was actually shocked. So whenever Atul came over to me and asked me to come and present here, I actually did have butterflies in my stomach. So can you all hear me there? Yeah, thank you.
Okay.
We can have this all integrated into an observability platform, and how you can use most of the open source tools, plus everything that we've been seeing all about securing Kubernetes at a go. So what are the topics we are essentially going to cover today? We'll just see some of the security concerns which we know about on multi-tenancy environments, and we can identify, classify some of the risk elements, 4 different types of risks which we will be looking at, and we'll also have a small demo to show you the same, followed by how can we go ahead and develop a framework to protect against these risks, and how do we achieve that end-to-end multi-tenancy that's all the way from the code to the cloud. So these are some of the things that we will be discussing in this short 30-minute window. So let's start. What is multi-tenancy? What is single tenancy? When I first created my Kubernetes cluster, it was just a normal unmanaged cluster that I created. I had all the resources in the cluster to be used, and I had some of those pods running. I was very happy, but I don't think I made my organization very happy with just using that one cluster. We were using a lot of clusters, or we had folks who were, or organizations coming to us for using a large number of clusters because they had a lot of applications to be deployed. So when we had organizations or people coming to us, what happened is there were some key performance indicators that they came up with. One being cost optimization, which is the most important. They did not want to have a lot of costs coming up from Amazon or Google or Azure into their buckets. Next is we needed to see how we could better utilize our resources which were there in a single cluster to have at least, copies of our application running. So that is the basic concept by what we talk about in terms of multi-tenancy. You either have multiple applications or the same instance of the application running on your cluster, utilizing the available resources effectively. So when we talk about multi-tenancy, it brings in a lot of good things to us. For example, we have scalability improved, we have our costs reduced, and we have our resource usage also on a better scale. But when we talk from a security standpoint, when we have a lot of these things happening, we have a lot of applications running on the same cluster, we have a major issue of having one tenant giving one tenant the isolation that it requires from another tenant. And when we are trying to achieve this, there are other threat actors available in the market who's coming to try to see whether they can steal things out of this, because we're using shared resources across. So that's where a security person has to come in to ensure that, whatever one tenant sees is not available to another tenant. Simple example, I log into my HDFC bank account in the morning today, and I'm able to see Rajasekhar's details. I think I'll be happy seeing those details, but that's not my details. There is some data that's gone across, and that's not what we are expecting. So how do we go about it? Now, let's consider a thief just entering into your house. He would have some kind of things that he would perform there. Simple example, which room is he in? He's got the initial access, so he's not moved in from your front door, he's jumped in from some window, or he's come from your back door. He's moved in, he's going to go check what are the security cameras available, what are the valuable items which are available that he can take and go back, and from that specific space that he is in, he can also go into the different places into your in your house and also do whatever he wants to. Now forget the thief and the house. Let's consider a cluster and a hacker who comes into this place. Simply put, an exposed pod somewhere is the only thing that he needs to gain entry into your cluster. Once he gets that entry or that initial access, he can go forward, check all the audit logs which are there. That gives him a lot of information about your sensitive data, where your secrets are, what is happening. And with that, he can actually laterally move across. That is, you can move across from one tenant to another tenant, and then finally maybe reach up to your S3 bucket where all the information that you have is stored. And how can you achieve this? With whatever Kubernetes itself provides, your RBAC controls as well. So this is a way in which a threat actor would come in, make the exploit, and then leave, and you wouldn't even know about it. So how do I go solving this problem? We've discussed some of the risk factors which is already existing within Kubernetes or within the environments that we are using right away. So it's better that we want to achieve security. You can see enforce OPA gatekeeper policies. You can have network policies specified. You can have a lot of monitoring tools like Prometheus or Grafana being used. All that is going to be helpful, but how can we get all of these together to see that, okay, I have done my admission webhooks, I've provided my network policies, I'm able to see things, but on the final go, if you're planning to give only very minimum access to your cluster or to the resources in your cluster, every developer or every person working on it would find it so much more difficult to develop things. So with keeping all those considerations in mind, we have classified those risks into identity, network, supply chain, as well as the runtime and storage risks. So let's move on to the next slide, where we will actually consider each of the risks, and we will also see a demo of how we have an observability platform built out of this. Now, in case of an identity risk or any solutioning that we think, I have parallelly taken a small reference from our MITRE attack framework. If all of you know about it, we have a set of techniques, we have a set of sub-techniques which are defined there. So these are the ways in which an attacker can come in, an attacker can exploit, and what are the type of attacks or attack paths that it can take. Things like that are defined there. So in the same format, I've taken three components here. One is the initial access. How did he get the entry? Lateral movements, how did he move across? And also the data exfiltration or the exploit, the final part where he takes away whatever is your thing. Now, let's take this example. I have 3 teams, which are nothing else but 3 tenants on a cluster. Now, there is a threat actor who finds out that there is a pod exposed somewhere. He gains access to that pod, and then what happens is, in Kubernetes, whenever you create a normal Kubernetes cluster, specifically in managed cloud services, what happens is you have the auto-mount service account token always set to true. So that means anybody who gains access to your cluster can auto-mount service account tokens. And that actually gives a lot of capability to that threat actor. Why? Because most of the service accounts that you have, or the namespaces that you create, would all go into your default service account. Now that default service account gives overly permissive, that is an overly permissive account which gives access to other namespaces which can exist in other tenants. Or here we have each tenant given to one namespace. So then with that specific default service account token that he got access to, you are going to be linking that service account to some namespaces which were associated with that default service account. And those namespaces will also have a set of role bindings associated with it. And in those role bindings, if at all you give a lot of privileges or permissions, for example, an escalate permission on a pod, that's it. You escalate, the pod can become a privileged pod. Easily, you can gain access to everything that's there in your S3 bucket or even to your secrets. So that's how we initially started, just with a pod. We moved across with a service account. We combined the service account with a namespace. The namespace got associated to role bindings. From the RBAC controls, we were able to get more capability in order to get into your S3 buckets. So that is the example that we saw. Now, let's show you how we can have a solutioning done around this. Now, this is basically a detection that has got generated. That is basically an alert that is being generated because a pod was created with overprivileged service accounts. And if you look on that other side there, you can see an attack matrix, which shows it is a privilege escalation. Now, moving here, you can actually see all details of which is that service account which was used, the specific service account's name. Now, we've got details to the service account. Now, we need to also know what are the specific set of privileges that that service account has. Okay, so now here, if you're going to be filtering by the name of the service account that we found out there, you would be able to get details about all the permissions which are given or the privileges which are given to that service account. You have get, list, etc. And what are the other set of pods which are associated with that service account. And we can also see that those pods had vulnerabilities detected in each of them. That means it makes it much more easier for the attacker who comes in to scrape through your whole system. And here what you can also see is the set of workloads where you are able to see wildcard permissions given. So a wildcard permission given makes it much more easier for an attacker. You just scrape through faster than ever before. So that is how we actually can generate or move from an alert that we received or a detection that we received all the way to figuring out or digging deep down into the service account, moving into a specific pod, getting details of the pods and the vulnerabilities, and finally we can actually build policies over on these such that we can make use of Kyverno or we can make use of OPA Gatekeeper, create policies based on this so that we have proactive monitoring which tells us that, okay, you know what, we've just done a small audit on your system today in the morning and we found out we have these many failures reported on this specific policy. That gives you a clear picture of something going wrong, which you can look into. That's how we went about identity risks. Now, moving forward, we're just going to be talking about supply chain risks. The topic by itself is huge. So I'm just considering 4 components to just talk about how code makes its way all the way to the cloud. Simply put, you write some code, a developer writes some code, puts it into GitHub. From GitHub, moves it into a build tool like Jenkins. From there, you store it somewhere. And then you pull that image, deploy it as a pod which is running into your Kubernetes cluster. This is a simple example of a supply chain I'm considering to explain. Now, when we have this supply chain components, we need to make sure that each of these components in the supply chain are risk-proof. That means each of these components shouldn't be detecting or shouldn't be reporting vulnerabilities, should be compliant, okay? And we should also make sure that we do not have any malwares or secrets getting reported. That is in each of these components in silos, as well as when that piece of code moved across these components, all the way from point A till the point it reached your Kubernetes cluster. So that whole chain of events can also be something that an attacker is looking for. So the minute he sees there is a vulnerability in your Jenkins build, or in your Jenkins machine when that specific image was getting built, that's it. That's so much more easier for him to start the attack at that point, and we wouldn't even know. We would maybe know this only when at the point when you deploy that image in your cluster, and then the image, if you have a monitoring system, the image which is deployed, or the pods would actually show up with vulnerabilities. So you have to go back and then look at 4 important components when you consider the supply chain risks. 1, you need to scan each and every component for vulnerabilities, malwares, secrets. You need to achieve some amount of traceability. That is, where to where did we go and how can we move back and see what is happening. Then we go into provenance, which is nothing else but You need to see what was the security of each of the components when there was action happening and when it was all in silos. And an integrity. An integrity is more about using something like cosign, etc., to give a signature to your image. So that is at least giving you confidence your image is free of many things. It's more like achieving, you know, or providing a certificate over. So how do I see this whole thing that I explained in action so that we can already have an idea of the vulnerabilities getting reported? So now this is just a small place where I have some of my clusters. And in this specific cluster demo, ATK, I can actually see that in that specific namespace, within that pod, there are vulnerabilities being reported. So there is an image that is deployed there. You select the image, you can get all the details which are associated to the image. Now, you can see that it has already been co-signed. So that signature is already there, which means it's safe. But still, we are able to see vulnerabilities getting reported, right? So that doesn't look all that great. So let's go deep dive and then see what exactly happened there. So if you look at this picture here, it basically shows you the whole path the code took, all the way from the time it was created, a commit was raised, a PR was approved, to the point where it reached Jenkins, and then it made its way into JFrog repo, and then it got deployed into any of your clusters. Okay? So you can see there is some amount of reports which are generated all across the path. So let's go deep dive and then see what each of the reports look like. So now let's go click on the cluster. So on the cluster end, you can see let's start from the pull request. So this is basically essentially the pull request that was raised. So we've done a round of checks on this. How many violations were reported? How many commits went through? How many reviews did we get? Okay, so each of these are parameters which we have considered for monitoring what has gone wrong at GitHub end. And we can also make use of GitHub Actions that's already available on GitHub to make sure that, okay, we have this amount of code verified. So it even shows us who is the person who approved it. So usually we need to have at least 2 approvers. So here we've got only 1 approval, and it's already gone through, and we've created a big blast at our production. So we're going back to figure out what's happening here. Now this is at GitHub end. We can use code control. GitHub controls are also available. So we've also integrated that extra specific controls along with the controls we have given. Now this is more on the repository end. So on the repository end, we can also use some compliance standards to do your checks. So that will give you more clarity that, okay, your system was compliant at that point in time when that image was pushed into it or it was built. And you can deep down, and this is basically showing you more details on what were the vulnerabilities which were reported at that specific point in time. So this is happening all at Jenkins. That was our build tool that we used. So we've done checks over there. But that's what I'm trying to show at the end is, even though it was co-signed, we had a signature which was given to it, we saw vulnerabilities getting reported. And then when we traced back all the way, we were able to find that the vulnerabilities were generated right from the point where the code was actually pushed into GitHub itself. And each of those vulnerabilities rolled like a ball and then became a wonderful thing at the end when we deployed it as an image inside your specific cluster. So that is what we actually had in terms of supply chain risks. And Rajasekhar will just take you through the network risks and a demo followed by a wrap-up.
Hello, you can hear me, right? Yeah, so I'm going to cover the network risk part of thing. So what is a network risk in a multi-tenancy Kubernetes environment? So basically, if there is a pod which is exposed to the internet through misconfigured security groups, I am talking about a EKS environment, AWS environment. So I'm taking a EKS cluster as my example. So if there is a pod exposed because of the misconfigured security groups, attacker can get the access to that pod, and then he can navigate to other tenants' pod if there are no network policies configured. Basically, we have to use the Cilium based CNI or the Calico based CNI, where we can configure a proper network policies to allow communication between different services running on a pod through the labels or through namespaces or the port ranges you can specify. So suppose if there is a database service running on a specific port, you can have a rule saying that it's only connect to the database service from the guy who is inserting into the database or reading from the database, not to the other services which are running. So we can have those kind of network policies. So if you don't have those kind of network policies configured, so the attacker can connect to a different pod, and then if they have host access configured, and if that pod has a privileged access to host network, he can connect to the host as well, because he has the access to host network. So there are tools, MITRE tools, which attacker can use and gain access to the host machine where that pod is being running. So with that, once he gains access to node, he can stop the services running on that. He can gain the entire control on that node, or he can move to other EC2 instances on the EC2 instances on the AWS platform, and then he can connect to S3 buckets, or he can do whatever he wants once he gains access to all EC2 machines running on your AWS cloud. So how do we avoid those things? So I'm going to explain how to. So basically, have a network policy which always denies communication between namespaces or the pods which are running on your system, and then open the connections or open the policies which are needed. So let's say database connection, it's only required. So open the policies for that particular port, and then you can measure the network exposures by configuring the network policies properly or security groups properly. And then, that's CNI policies always enforcement mode, always deny the communication between the namespaces across the different tenants. So that will avoid lateral movement between the different tenants. And then the next thing is you should always deny host network. Don't use a host network set to true in your deployment AMLs. So it can cause, basically the attacker can gain access to nodes. So I'm going to give a simpler demo where we can see all these things stitched together. We can see the data exfiltrations from S3 bucket. So this is one of the risks we are showing here on this cluster. So this is host network access with a container, and then malwares are also running. Yeah. So this is my pod or the container. You can see this has an internet access. Can you? Yeah. Yeah, so this has a open port 22, and it has a vulnerabilities also, that container which is running on that my cluster. So attacker can, because of that vulnerabilities and then misconfiguration, he can gain the access to that pod, and then there is a host network access given to that pod. That's a misconfiguration in the pod level. So with that, he can gain access to EC2 instance where it is running. So from there, he can gain access to other EC2 instances, and then he can get the control to IAM roles, and then using that IAM roles, he can access to another EC2 instance, and then because of the IAM rules allows a permission to access S3 bucket, he can delete, he can edit, or he can do whatever he want to that S3 bucket once he gains the access. And then he can delete entire your S3 bucket data as well. Any questions, anything? So we can show this end-to-end in our application. So we have capabilities to show all these data collections available. Yeah. So next thing is runtime and storage. So how to avoid this runtime and storage risk? So try to not to use global resources across different tenants. Always configure cluster roles, cluster role binding service accounts specific to your tenant. Don't use wildcard privileges or wildcard resources while configuring the service accounts. The next thing, whenever you have a persistent volumes being used in your pod or container, whenever the pod goes down, right, please try to delete your persistent volumes as and when the pod is going to shut down. And then for each tenant should have storage class specific to that tenant. So that's, we can avoid the cross data between different tenant. The next thing is just use the pod security policies to prevent accessing the host and file systems between the pods and between the EC2 instances. Yeah, and then avoid using global permissions to webhooks. Don't give global resource permission to webhooks, because webhooks directly communicate with the API server, and then it can gain access to entire cluster. So now how I'm going to explain how to, like, we covered all these things in each sheet, but I'm going to cover end-to-end multi-tenancy security from code to runtime, how to achieve this at the code level, pipeline level, Kubernetes control plane level, and container runtime level. At the code level, we can use IAC scanning techniques, where we can scan our KDS deployment. Whenever there is a YAML file committed to your GitHub, so we can scan that YAML file, see whether there are missing resource limit, or that YAML having privilege escalations added to that, or any misconfiguration, security context being used, or privileged configurations are added. We can identify using the CIS checks. The checkhouse provides a CIS checks where we can identify those kind of misconfigurations. And then we can scan for the packages which are using and the jar files or Java files. If you are using a Java, so you can scan those jar files, and then exe files are the packages which you are building during the code itself. So you can report them as well. And then during the software pipeline, so we can, once you check in the data, so during the build time also, once the image is built, we can scan for the images. For the vulnerabilities, malware, secrets, we can report that information to the user. As Sneha mentioned, there is image provenance, so we can detect the root cause of the problem, where that code or where that package is being introduced into your image or into the pipeline. So we can identify the root cause at the initial stages itself. The next thing is Kubernetes control plane. So always have network policies configured, and then use the deny mode always on, and then open ports ranges which are required to your tenant only, specific to your tenant. And then you can have RBAC configurations based on the labels within your tenant only. Or if you want to communicate with the different tenant, which is allowed, have that labels properly to the pods which need the communication between different tenants also. The last thing, the container runtime environment. So always have event rules configured, and then get the detections, and then remediate them on time. And then we have ARA processing capabilities, where we can scan for malware process running on your system. And then we do have image policies configured. We can have policies on Kubernetes environment, where we can deny any pod coming into system, any malicious pod or any vulnerable pod coming into your system. That's how we can achieve end-to-end security from code to runtime. That's it from my end. Any questions, anything?
Thank you so much. Have a huge round of applause for both of them. I request Kapil to give away a memento to Sneha first. Please hang tight. We'll be also having group photo now. Yeah, it's for Sneha first. And have a huge round of applause. We'll be having... We'll be also presenting memento to Rajasekhar. Have a huge round of applause for Rajasekhar also for presenting us well. Now hang tight. We'll be having a group photo now.